Today we're going to fix a problem that is very common to the Ford Econoline class vehicle. In fact, it's so common it happens almost to every vehicle, and it's been a problem for almost ever when it comes to the Ford Econoline class, and that is the heating and air conditioning blower motor switch. In this video, we'll be replacing the blower motor switch, the resistor, and the blower motor. So what exactly is the problem with the blower motor switch that requires it to be replaced? As you can see, there are no clicks as you move from position to position. It's just a smooth transition from low to high. There should be individual clicks for each position of the switch for different speeds of the motor. Normally in high current situations, a switch is connected to a relay, and when the switch is closed, it closes the contact on the high amperage side of the relay, allowing current to flow to the high amperage device. What Ford did was take the switch and connect it directly to the blower motor, which is a high amperage device, forcing the high current to move directly through the switch instead of using a relay. The high current flowing through the switch would heat the connectors as well as the internal components of the switch. As these heated, they would begin to oxidize, which would increase the resistance of the connectors and the components, thus creating additional resistance that would eventually char and burn the switch components. Potentially, this positive feedback loop could cause a fire, but more often than not, it just resulted in the switch becoming inoperable. And in all probability, that's what's happened here. So let's get started by taking off the dashboard. As you can see, I've pulled the dashboard off and up and over the gear selector. Here's the switch that needs to be replaced, and if you look right here, you can see it's all melted. Let me give you a better view of the switch, and as you can see, it's definitely charred. There is a lower switch, but that's for the fan in the back, and that one's in good shape. But the first one is definitely a problem. Here is the connector side. Look how melted that is. This is a result of absolutely poor engineering on Ford's part. Here is the replacement Motorcraft switch with the wiring pigtail already connected. With the new switch identified, let's get started doing the replacement. To replace this old switch, use a 1/4-inch nut driver and remove the screw. Using magnetic bits on your nut driver is always beneficial. Now simply twist the switch and remove the tab from under the latches, and the switch will pull free. Of course, you do have to remember to take the switch knob off the front. Now you can see the level of damage on the switch. If you had any question as to why the switch didn't work, the level of charring should be a good clue. Now place the new switch onto the plate and twist the tabs under the latches. There is a latch and tab on this side and one on the other side. Now replace the screw and using the 1/4-inch nut driver, tighten only hand tight to prevent damage to the plastic. The coloring of the wiring on the pigtail does not match the color of the wiring on the original connector. As such, we're going to have to do the connection wire position to wire position. I've placed the old connector on the new switch, and by comparing the new connector in the position that it will rest, we can see which color wires pair to which color wires and in which position. I've attached heat shrink butt splice connectors to the wires of the pigtail. The yellow connectors are for 10 gauge to 14 gauge, and the blue are for 14 gauge to 16 gauge. It's hard to see in the video, but the two wires that have the yellow butt splice connectors are actually heavier gauge, just slightly, than the wiring with the blue butt splice connectors. I cut the old connector off, and by matching wire position to wire position, I've crimped the old wiring onto the pigtail. The butt splice connectors have all been heat shrinked. I used a butane torch to shrink the tubing, but you can use a heat gun or whatever you happen to have handy. In order to remove the dashboard, several connectors had to be separated in order to move the dashboard over the gear selector. Now is the time to reconnect all of those electrical connectors that you separated once you've repositioned the dashboard. And do not forget the connectors that are out of line of sight, such as this dimmer switch. Ensure the wiring is out of the way of the dashboard and it should press right back in. Now test each of the switch positions to ensure a change in the velocity of the air. Now finally test the system off position to ensure there is zero airflow. Now it's time to replace the blower motor and the resistor. They are both located on the firewall behind the battery. Now the question is, does the blower motor and resistor need to be replaced? The answer is no. The switch inside is working just fine. The issue may rise, however, with the resistor, as it heats also very similar to the switch, and therefore can oxidize, create additional resistance, and eventually burn out. The resistor itself controls the various fan speeds depending on which position the switch is in. The blower motor has been in the vehicle since 2012, and since you have to remove all of the same components to access the resistor, the opportunity arises to replace the blower motor as it's not that expensive. We start by removing the battery. In this particular case, an 8mm socket to remove the cables from the posts. Your mileage may vary depending on the cabling and battery type in your vehicle. The battery is now removed. You can see the resistor as well as the blower motor right behind the battery tray. The next step is to remove the battery tray as it's blocking the blower motor. We will also need to remove the two bolts securing the air conditioning dryer to the quarter panel. This will provide just enough play for the blower motor to slip past the air conditioning dryer. With the battery tray removed, you can clearly see and access the resistor and blower motor. The air conditioning dryer freely flexes after removing the two bolts. The blower motor has now been removed, as well as the resistor. You'll notice that the resistor elements are actually inside the air plenum, and that's a means of cooling the resistor elements, as the only time they need cooling is when the blower motor is on, so there's always airflow moving across the resistor elements. Here is the old resistor element. You can see it's heavily corroded, and that's probably caused by moisture in the air plenum, so it definitely pays to replace it. Here is the new resistor compared to the old one. At this point, we want to make some comparisons to ensure they're the same part. So we're looking at the number of resistors in there, make sure they look similar, make sure the screw holes line up, as well as the connectors and the connector orientation. The resistor has now been installed using two 8mm screws. When installing the resistor, ensure that it's flush against the plastic so there's no air leaks, and tighten the screws only tight enough to hold it firmly so as not to crack the plastic. The new blower motor with squirrel cage comes with a foam gasket with double stick tape on it that must be installed prior to placing the blower motor into the plenum. Align the foam gasket so the registration pins and screws are not blocked. The gasket is now secured to the new blower motor, and it will create a very good seal against the air plenum. One thing to note on the blower motor is this hole right here. This is a cooling hole. And what this does is attach to this cooling hose. The hose slips into the hole, and the elastic band goes around the motor to hold it in place. The other end of the hose connects to the air plenum to provide cooling of the motor from the pressurized air in the plenum. The blower motor is now installed using 8mm screws. The cooling hose is also connected with the rubber band over the top, as well as the resistors. Here is the connector for the motor, and that should slip right in over the lock. The resistor connector slides right in with locks on either side of the socket. Now the last things to do is to tighten up the air dryer, replace the battery tray, and reinstall the battery. The battery tray has been replaced using 12mm bolts on the left and 13mm bolts on the right. The battery is now installed, and the next step is to start it up. The blower motor switch, the blower motor, and the resistor all work great. If you like what you see here, please consider liking and subscribing.